2.3. Suppose that big X denotes the amount of rainfall in your hometown during a randomly selected month, and big Y denotes the number of children born in Los Angeles during the same month. Are big X and big Y independent? Explain. Answer. 2.3. Although there is no apparent causal link between rainfall and the number of children born, rainfall could tell you something about the number of children born. Knowing the amount of monthly rainfall tells you something about the season, and births are seasonal. Thus, knowing rainfall tells you something about the month, which tells you something about the number of children born. Thus, rainfall and the number of children born are not independently distributed. 2.4. An econometrics class has 80 students, and the mean student weight is 145 pounds. A random sample of 4 students is selected from the class, and their average weight is calculated. Will the average weight of the students in the sample equal 145 pounds? Why or why not? Use this example to explain why the sample average, big Y bar, is a random variable. Answer. The average weight of 4 randomly selected students is unlikely to be exactly 145 pounds. Different groups of 4 students will have different sample average weights, sometimes greater than 145 pounds, and sometimes less. Because the 4 students were selected at random, their sample average weight is also random. Suppose 2.5. Suppose that big Y sub 1 through big Y sub n are independently and identically distributed random variables with big N of 1 and 4, or with the normal distribution of mean 1 and variance 4 distribution. Sketch the probability density of big Y bar when n equals 2. Repeat this for n equals 10 and n equals 100. In words, describe how the densities differ. What is the relationship between your answer and the law of large numbers? Answer. All of the distributions will have a normal shape and will be centered at 1, the mean of big Y. However, they will have different spreads because they have different variances. The variance of big Y bar is 4 over n, so the variance shrinks as n gets larger. In your plots, the spread of the normal density when n equals 2 should be wider than when n equals 10, which should be wider than when n equals 100. As n gets very large, the variance approaches 0, and the normal density collapses around the mean of big Y. That is, the distribution of big Y bar becomes highly concentrated around mu sub big Y as n grows large. The probability that big Y bar is close to mu sub big Y tends to 1, which is just what the law of large numbers says.